Hi guys, this is Andrew at Flurry PB, and I'm back at the lathe here. After we did our little test run, let me see if I have light. I have light. We did our little test run. It worked pretty well, but in order to make some of the parts, or all of the parts I want to make, I need to have a drilling capability with this too. I can't just turn, I need to be able to drill. It does have a tailstock, but I'm not going to manually drill stuff with a tailstock. So I still got to clean this up a little bit, and I got to do some work. So two things it has. When you look back here, this is actually on a dovetail. And I seen another person has a similar lathe. They're a Mechanica Cortini like this. And they have a gang block set up that I guess slips on this dovetail. And you can mount gang blocks to it. And you can gang tool off this, which is really good for drilling. But I don't know if I'm into doing the gang life at this point, just because I don't have a block of steel big enough to do that. I'd have to make it out of aluminum. I don't have the block, I think. So I'm going to break into my cabinet that has been shut for a very long time. I'm going to try to break into this cabinet down here and try to see the fixtures and the tool posts I have, because I have more of these, but they're locked in here. I have collets for this, but they're locked in here. I have schematics for the electronics for this, and they're locked in here. And this is going to be part of my next plan, is what I'm going to do after I get into this cabinet. So I'm going to break into this cabinet real quick, and I'll be right back. Alright, so I popped the lock. I popped it once before. Here's my keys, right in there. But we have a lot of stuff in this cabinet. Let me... cabling, more cabling, these things that died on me. We got more cabling, stuff that doesn't matter. This is good. There we go. The maintenance manual. Put that up there. We'll look at that in a second. What else do we got here? Foam. Alright, here we go. So, we have a whole set of collets. I believe when I was doing research, these are W12, which are like a Schaublin brand. And I have the collet chuck right there, which is awesome. Don't exactly know how that goes in, but there's a collet chuck, and I have more of these. Which these are, I don't know if you can see them. Sorry. I have more of those. So that was what I was hoping I had. Because, let's move this. These are the custom tooling, or the holders. They're really nice pieces. But I have 6 of them, and this is a 6-station changer. So it allows me to put more of these in. So my idea is going to be, and I also seen the same guy that had the gang tooling had one of these blocks, which I don't know if they're made. Let me get the light up here. I don't know, I couldn't find where to buy the block, but it's a tool post that sticks out like this, a 3/8 tool post. But here it has a hole so you can put a drill. So my theory is I can go to a place like Oshcut, which does laser cutting of steel. And I know they have 4140 pre-hardened and ground 1/2-inch stock that you can get cut. I'm going to do a design real quick, and I'm going to cut out something that fits in here that has a hole here that I can probably press in one of those cheap ER11, ER20 little collet holders into it. So that's going to be my goal, is to get a couple of those made to fit into these, which are just 3/8 setups. And that way I can have some tooling that I can drill with, so I can start doing some of the cooler things I want to do. Let's go back in this cabinet now that I have it open. So you have the collet closer. I have a bunch of holders. I don't know what I don't know what these are for, but they're in there. Oh, let's go down. I have the other literature, which I'm going to need because I need to break into the, or I need to figure out what's going on with the inductives, the inductive sensors and everything. I would like to have those going too. Why do I have router bits? 2 flute long boys. Huh. Okay. I don't know why those are there. That's probably trash. I have a Commodore tape system for that's like 1980s tech right there. What's in here? Couple batteries for it. Holy shit. Okay. So the Commodore tape deck system to do some of the like transporting files into the machine. I have another ring. This is my non-broken one for my encoder ring. And I have another cover for the encoder ring, which is cool, with a lock. It actually has a lock spindle on, which is really, really cool. This is a really cool little lathe. But alright, I broke it in. I have keys. Let me see if they're the right key. And it's not the key to that lock. Huh. Is there anything underneath here? Nah. Huh. Is this the key to this lock? So I have 2 keys that do not go to that lock. Maybe they went to the original power button. But, yeah. So it broke in. We're through. Next step is I'm going to clean this thing up. Get all the shit off that doesn't need to be on it. And, I'm going to start going through the literature. I'll try to bring you guys along when I get somewhere on that. That's a cool little milling machine. I'd like to have one of those too, honestly. I want to put the back cover back on, just to get some stiffness back here. It's that gray thing sitting right there. If I get that plate back in there, it's going to add some rigidity to the frame. There was some kind of plastic cover that went up here on that. There's a back cover for that box, but I think I'm going to leave that off for right now. And yeah, I just want to get the stiffness back. I want to get it kind of in game shape. And then I'll cut to me designing the holders to go in there for the drilling operation. And yeah, we'll just keep taking it from there. This is the start of the next video on the lathe. To act with the 4140 hardened and trying to do something else with it more conventional. Something the machine warmed up and get going, and yeah, you'll see me cutting. So this is the tool changer holder for my CNC lathe, for the tool changer that's on it. And I wanted a way to attach a collet drill setup. So, like, something like this. I would like to embed a little crappy collet setup into a piece that can then be put into the tool post holder in order to drill and keep it on the CNC carousel and not deal with a gang setup. So I figured out how to make these, and these are laser cut out of 4140 hardened steel, so semi-hardened steel. 4140 is not super hard, but it is hard enough, I think, for this application, and it's about 1/2 inch thick. Problem with that is when you laser cut something like this, comes out not bad, but there's a taper on it. See that taper? Which honestly might not be the worst thing, because then it, like, put the taper right and you bolt it down, it could work. But I figured, let me clean that up and make the sides flush and go from that. And then when I have that set up right and where I want it, I'm going to bore this in the lathe itself to center it to the spindle. So then I have a nice concentric setup there. But I have 5 of these, and let's get the setup for you. So I don't know why I'm relying on these so much, but it's just working so well. But I have the 2, 4, 6 blocks. I have 2, 1, 2, 3 blocks bolted up. I machined 2 pins, there and one in front. They press through, and that's just to locate this down and locate it this way, so I can machine this side, flip it over, locate it again, machine the other side, flip it over, and have a common 0 point. And then the blocks are just tied to the blocks, which is tied to this big aluminum plate. My bit is for aluminum. Has a bunch of stick out, which I'm not super thrilled with. I'm not super thrilled with either of those, but it is carbide. And I figured the carbide's better to act with the 4140 hardened than trying to do something else with it more conventional. So I'm the machine warmed up and get going, and yeah, you'll see me cutting. Alright, we're going to touch off 0 back here, 0 the bottom, and start going from there.
Yeah? Are you almost done?
No. Definitely got some time left. Guess this is harder than I thought it was. Alright, we gotta try something else. This is harder than I expected it to be.
So I don't use this machine very often. My knowledge of it's very limited, but I actually don't even know if this is square to the wheel, but that should be okay. This is a surface grinder, and this can cut this regardless. So let's give this a shot. Touch off.
All right, let me grab the yeah, okay. Okay. That side is nice. Nice and cleaned. So I know I'm going to, oh, I don't even have a gauge on this, so I can't even do that. But now if I flip that over and coordinate that in, I can cut the other side of it too. But I'm going to cut all 5 of them on the one side first. All right, so I completed all of the first sides. I cut that too on both of them, just because that's more cosmetic than anything. But now let's we're back in the vise or the setup with our ground flat side on it, so that should be squared up, hopefully squared up to something. Doesn't matter, it's more aesthetic than anything, but still. Oh, that looks square. Nice. So we're squared up now, hopefully squared up. Piece there, couldn't get, whatever. But yeah, I'm gonna do the other 4 and get back to you when I have them all laying flat. I just want to clean up this face real quick with this, just so it works. I redressed the wheel between operations. Yeah, that's it. I'll get back to you guys when I get all of these done, because it's a lot of just repeat. All right, so we are just going to finish it by facing all of these, just to get rid of the heat soak that went through it. Making some moves here. Obviously, we just faced this stuff. That was probably the last thing you've seen. Still got to deburr it, but we'll do that in a separate thing. I want to talk about my my holders. So this wasn't my original plan, but my original plan was to use these, which were some super cheap ER11 collets I could get off Amazon. They're like $8 or $10 a piece, and they have this little shank. And I was gonna bring this down to just fit inside here and press fit it together. I was a little worried about these because they're just some Chinese garbage, and who knows how good it actually is. I was gonna grind this down off and put the plan was to, in my lathe, turn a piece, put an ER11 collet in here, tighten it down on that, and then grind this based off of a collet that's in place. But who knows how good these are. So I was looking around, and Haas, of all places, was having a great deal. These are made in China, but these are ER16s, or yeah, ER16 collets from Haas, made in China. So I imagine it's probably similar quality like a Shars product, which isn't a bad quality product by any means. It's actually pretty good for what you get with like a Shars product. But they're having such a discount that like these things were half the price of a Shars thing. So they're like $25 for that a piece, and it's like, well, might as well just do that. I'll just bring this down to sit in there, and I'll bring this up a little bit because I don't really need this much wall for it anyway. And I'll press these in, and then I'll have ER16 so that I can use up to a 3/8 inch drive, or 3/8 inch shank instead of, I forget what ER11s do. And like, they even had, look at this little kit. They had great deals. These were like $40 for a whole 10-piece kit of ER16s, which was, again, like half the price of Shars on the sale they were having. So, I mean, yeah, these are Chinese. They're not ideal, but they're being sold by Haas. So, famous last words. The hope is that they're decent enough for the things I want to do with them. So, I'm going to bring you guys to the lathe and show you me cutting this down. This is not hardened, but it is very hard. So, it's not hardened, though, but it's quite hard. So yeah, I'll show you me cut one of these down, and then we'll switch over to the grinding to grind this shank down to size that we want, and that'll be next. Let me see if this works. You're kind of in my space. Wobbly. See, there's a set screw in there. I don't want to... I think I got it. All right. There we go. So, sorry, break that off. So yeah, I have the set screw in there. I just wanted to get it close enough. I shattered the first one, not realizing it was there. And once I got tight, this twisted on and blew up my first insert. But since then, it makes it significantly easier to actually, you know, hold these things, which is nice. That up there. So you have the 5 parts cut. Next, we're going to switch over to setting up a dowel in here, and I'll grind that in, and then we will tighten these onto that with the 3/8 collet, and then grind these all to the same size. right. Wasn't going for a polish finish on these, but yeah, it's pretty good. And yeah, that's going to be this part of this step. Gonna knock down the burrs and get them mounted in the tool post, and then put that on the lathe and show you the next process. Alright, so I trued this stone. I just got to take a pass on this just to clean this up. This is the very cheap setup I have. So much vibration in this thing. Okay. So that should be a shaft. So if we I do not think that went through fully. Need a little more room. Okay. So hopefully that's concentric. Not concentric, but let's see. Well, it's round, which makes sense. It's very flat. That's good. So that's a good little sanity check for myself there. I wonder if I have to go down the size now. It's no longer 3/16, or 3/8. I mean, let me. Okay. So let's spin this, see how it looks. Not bad. Yep, screwed it up. 15.98, 0.02 millimeters is it ain't much. It's a tenth. So 0.02 millimeters, tenth of an inch. So I'm tenth of an inch light on this one. I'll just remember that. I'm gonna do the other 4 the same way. I'm shooting for 16 on all of them, and I'll just break these 2 edges. But I'm gonna do that with the camera not in my way. So I'll probably redress this between, just to make sure it's nice and clean. But that looks good. That should be very cylindrically on center to this, because this was ground in a lathe, which is a pretty precise piece of equipment. It was ground. It looked very straight and concentric. This should have 4/10 or less run out in the literature that Haas gave me for the collets themselves and the collet holders. So hopefully this is within, within half a tenth, or 5/10 of concentrically straight and good, because then when I stack everything together, when I grind, I have an internal grinder that I'm going to grind in on the CNC lathe for these, and then when I press fit this in, hopefully I'm within a thou, because a lot of it's going to be small drills, so you want to be very, very accurate with your alignment. So hopefully I can keep it around 1/1000th of an inch. I'm trying to do for the alignment to get the drill fixtures going. But I'm going to do the other 4, and then we'll switch over to showing you the internal boring of this on the lathe. We're back at an interesting point in time here. I messed one up, which I'm very upset about, but maybe I'll find it one day and can fix it. But basically, I decided to blue these, so I don't have great light on me, but anyway. So I knocked down all the edges. I got all the chamfers in. Let's see if we can show you guys the chamfers and the edges. And I'm bluing them. Obviously, I'm going to let them sit in oil for a long time, but I want to knock in the center bores. And so let's go down to that setup here. I have this set up in the tool changer, and I have it centered to the lathe. This is a spindle grinder. Let me slip these out of the way. This is a spindle grinder, so basically it's like a boring head. It has an offset, so you can keep offsetting this, and then when you spin it, you see how it wobbles? So it acts like a boring head on a mill, but it's a grinder. And it's pneumatic. I'm just trying to bring this down to a reasonable temperature so I can get an accurate bore gauge. Fits. See? Thought I was too hot. So. One thing left is to press fit this in, and I'm going to do that off camera, and then I'll come back up and show you guys the finished product. Alright, so this is now the finished product. Pressed in. Definitely beat on that. I might blacken it a little bit more. Yeah, it'll go right into the holder. And center it up on the chuck. I know it's in axis with it. So ideally what I think I'm going to do is when I need to set 0 on these, I'll just cut a piece of stock that is the ER16 taper, and then I'll just push this up into that and get it locked in that way, and then I got zeros on all my drill pieces. But yeah, I'm pretty happy how these are turning out. Just got to do the other 3, and then I can start doing some projects with these. And oh, they got to stop too, because hold on. Yeah, so there's I could set stop lengths on the drill bits or whatever bit I want to put inside this thing. So I'm pretty happy with this. Definitely puts more utility in the lathe itself. Integrates into the tool holder. Doesn't affect anything. Will spin around it perfectly fine. Move you guys over so you can see it on the tool holder itself. See, it has plenty of room behind it, so as long as my drill bits don't stick out way too far past this black ring, it could spin and be part of the tool carousel without being a problem. And yeah, this it's been a long time making these, but I'm pretty happy how these are turning out. Hopefully the other 3 turn out as good as this one. Still a little heartbroken I didn't get the 4th one or the 5th one the way I wanted it, but is what it is. I can always make more if I need to. Definitely fun little project. Alright guys, this is Andrew at Flory PB, and that's it for this one. Next video I'll show you me actually making something with these. Alright guys, ooh, terrible lighting. Just have to deal with it. Clean everything up from the grinding episodes, and have the headstock fully back together right now. I put a magnet strip with the magnet here. For that, I have another one down there, and I put this on a magnet too, a USB strip that goes into here, just to try to a little better quality of life stuff there. So like that's good. WD-40 bottle. I 3D printed a bezel. Don't love it. It's just first attempt just to mount this. So this is mounted now, and that's just kind of the quality of life stuff to get this going a little better. And well, now let me show you the game plan for actually getting these things centered. I have a piece. This is polycarbonate, I think, in here. I've been fighting with ChatGPT, but in conversation, it has conversely produced a code for me. So what that code did or does is it produces an ER16 taper on this end. And so the idea is I'm going to cut a taper, which is going to be, you know, centered or squared up to your spindle. Cut a taper on it. Then I'll rotate my tool changer, put in the tool cartridge, and then when I put the tool on, I can slip it on the taper and zero it in the X and I guess Y height direction that way. And then you just set your Z when you put your tool in. So let me get to machining that. If that works. So that's an ER16 taper. Apparently it is. Let me check. I had to fight ChatGPT a lot for that one, but yeah. Guess it is. Looks about right. So we're going to take our tool holder. It's going to come in like that and just center up on that. And let me well, that's something to think about. I didn't think about that. This thing is so long that it's going to interfere maybe with this one. Maybe not. Probably make it work. Ooh. I'm just going to put a space between us. Okay, that should be set up now to be hopefully on center, very on center. Go drill bit. Looked like it didn't move very much, which is good. Just a piece of polycarbonate, but woo, it's hot. But we can drill now. So drill now, integrate into the tool rack. Clearly, I have to think about that when I'm doing it, but that makes sense to be that far away from it anyway. We shove another tool here eventually. But now I can start doing some products I've been wanting to do, especially looking at WDP mini regs. Trying to do a little upgrade path for those to make, hopefully get a little better performance out of them. Alright, that's finally it with Andrew Floyd PB. Next thing on the lathe is going to be maybe some video of making parts, and or I need to do the limit switches still. What I found out, I was trying to do some research on them. They are normally open PNP transducers, which are a proximity sensor. And typically, at least Mach, the way I'm familiar with it, it prefers a normally closed style switch, like a micro switch feel, not a proximity sensor. So my thought process is, instead of trying to go through Mach and the Warp 9 ESS board and all that stuff, because I'm sure it can do it, but I don't know how to do that, and I don't really want to research it. So my thought is I'm going to put a little MOSFET board between
the proximity sensor, feed the proximity sensor's power, and take the signal off of that when they close to fire the MOSFET to normally close setup like a switch, the way that Mach wants it as this is set up. And yeah, I'll go over that when I get the board. I have that ordered. Cheap Amazon little thing. I have that ordered to go. I'm very happy with this. I think that stayed very much on center. It didn't look like it walked very much. I'd have to put a dial indicator on it to see how good I did, see if I did perfect or not, but I think that's a fairly easy way to set these up. And then once I get my limit switches dialed in and get those in correctly, then I don't have to redo the carousel every time it crashes or something like that. Because at this point, if I don't have the limit switches set up, I'm going to have to re-dial in all the tools in the carousel each time. So I don't want to do that. After the limit switches, I have to figure out the encoder, rotary encoders, and get that part set up so I can have better control of the speed of the spindle, and then I can worry about threading and stuff like that just to make the lathe even more usable. But alright, that's it. This is Andrew Floyd PB. The lathe can drill now.